In this video, we're going to do a quick look back at the special right triangle rules. These are going to be very important for our upcoming unit where we learn how to build the unit circle based on the information used for 30-60-90s and 45-45-90 triangles. So first, to refresh your memory on the rules for the 45-45-90, the information I have here shows that whatever the legs are, I'm just using a variable x to represent them for a moment because sometimes it'll be 5, sometimes it'll be 7, whatever the number is. These two legs should always be the same because there's a rule for triangles that the sides opposite the angles will be proportional. So if two of the angles are the same, then two of your sides will be the same as well. Now the other side is the hypotenuse. So this one is the one across from the 90-degree angle. This will be whatever you have for the leg times root 2. The important thing concept-wise, there are basically going to be two cases for the 45-45-90. There will be the problems where they give you the leg, and if you know the leg, well, then the other leg's going to be the exact same number. So that means across from the other 45-degree angle, this one is also 6. And then to get the hypotenuse, we're going to multiply by square root of 2. So 6 times root 2 is 6 root 2. There's no simplifying to do on that one in this case. We'll talk about simplifying the radicals in a moment. Now the other way around is what if the question gives us the hypotenuse, so we know the one across from the 90-degree angle, and we need to find the ones across from the 45-degree angles. Well, for these questions, we're going to find the leg by dividing square root of 2. So if my hypotenuse is 7 root 2, I'm going to divide by root 2, and what happens in a case like this is the square root of 2's cancel, so that means my legs are just 7. And again, they will both be the exact same number, because they have two 45-degree angles, so the sides opposite those are the same. So keep in mind, if you know the leg, multiply by root 2 to get the hypotenuse. If you know the hypotenuse, divide by root 2 to get the leg, and then always simplify your answers. Now let's talk about the slightly harder case, the 30-60-90. So it's called a 30-60-90 because we have a 30-degree angle, a 60-degree angle, and a 90-degree angle. So in this case, since two of the sides aren't the same, we do differentiate between the leg names. So there's the short leg, which will be across from the 30-degree angle, and then there's the long leg, which will be across from the 60-degree angle. And then we use the same term for the side across from the 90-degree angle. We still call that one the hypotenuse. Now this time our ratio is a little bit different to go from one side to the next. The best thing to do is to start with the short leg. So if they gave you the short leg, awesome. If they didn't, I recommend finding that first. And then whatever this number is, you're going to multiply it by 2 to find the hypotenuse, or you're going to multiply it by square root of 3 to find the long leg. Just like with the last shape, if we're going backwards from the leg or the hypotenuse to the short leg, then we're going to be dividing by those numbers instead. So that's what I have written out here. If you know the short leg, then you're multiplying by 2 or multiplying by square root of 3. If you know these other sides instead, you're going to be dividing by the 2 or dividing by the square root of 3 to get your short leg. So let's look at our three examples that I have here on the side. First, I have the case where we were given the short leg because that's the side not touching the 30-degree angle. So if I want to find the hypotenuse, my rule says to multiply by 2. So 5 times 2 is 10. And then to find the long leg, I need to multiply by square root of 3. So 5 times the square root of 3, it doesn't simplify. I'll just leave my answer as 5 times the square root of 3. So that triangle is finished. Next case. Now I have the side across from the right angle. So we have the hypotenuse in this case. So to go from the hypotenuse to the short leg, it's going to be half of that length. Basically, I'm dividing by the 2 instead. So 20 divided by 2 is 10. And now I can go back to saying, well, I know the short leg at this point, so I can go back to multiplying to find the missing value. So to go from the short leg to the hypotenuse, I'm going to multiply by the square root of 3. Again, that does not simplify in this example. And then the last one, this is usually the hardest case because instead of multiplying or dividing by a 2, we're having to multiply or divide by a square root of 3. So I'm going from the long leg. I know it's the long leg because it's the one across from the 60-degree angle on this problem. So if you divide by square root of 3, the square root of 3's will cancel out, which means that my missing leg is 4. And then now I can go back to saying from the short leg to the hypotenuse, we just need to multiply by 2. So 4 times 2 is 8. Now, none of these questions were especially difficult on the simplifying because I want to do the simplifying of your fraction and radical answers on a separate slide. So this is just trying to focus on what do you multiply by and what do you divide by. And like I said, we will use this a lot on the unit circle. So now let's quickly talk about what happens when you're simplifying. One of the side lengths, one of the computations, and you have something like 7 over root 3 or 12 over root 2. When you're dividing by a square root, we have to remember that we do not like having those square roots in the denominator. So whenever this happens, we need to multiply your fraction, both numerator and denominator, by whatever your square root is. You only need to multiply by the square root. So if there's a number as well, a coefficient out front of that, don't worry about that. You only need to multiply by the square root in the denominator. And then when I simplify this, now on top I have 7 root 3 over 3. And then check if you can reduce the fraction anymore, the numbers, the coefficients out front. But in this case, I cannot do anything else. But if I look at this second example, again, I have this situation where there's a square root in the denominator. So I'm going to multiply top and bottom of the fraction by the square root of 2. I'm allowed to do this because that means technically I'm multiplying by 1, so it's not changing my fraction. On top, I have 12 times root 2, which does not simplify. On the bottom, I have root 2 times root 2, which is 2. Now this time, my fraction can be reduced. The 12 and the 2, since neither of them are inside of a radical, these can both be simplified to just give me 6 times root 2. So when you're going from the hypotenuse to the leg on a 45-45-90, or when you're going from the long leg to the short leg, sometimes you have to divide by a radical, so that's where these situations come up. If you have a square root in the bottom of your answer because the square roots didn't cancel for whatever reason, then make sure you do simplify them as much as possible. And that's it for our review on the special right triangles. Thank you.